everyone, so welcome to F.IF.2. We are going to be learning function notation. And now we use function notation to write rules for functions. And when I say rule, it could be in an equation. So we would write equations in function notation using this symbol. This symbol does not mean f times x. This symbol is pronounced as f of x. So it does not mean multiplication. And we use f of x in place of y when writing a function rule. So if I have the equation y is equal to 3x plus 1, to show that this is a function, I could replace the y with f of x is equal to 3x plus 1. So essentially, f of x is a fancier way of writing y. But we can only use f of x when we're dealing with functions. So for example, in our last unit, when we had x is equal to y squared, this was not a function, so we could not use f of x in place of y in that situation. All right, and now a couple of things to keep in mind is that f is not a variable. F is not a variable. What f means is it means that we're dealing with a function. Now, sometimes you might not see it as f of x. Sometimes you might see it as g of x, or h of x, or maybe we're not even using x. Maybe we're using d of t. Distance and time. So f of x is not always just going to be f of x, so keep that in mind as we're going throughout. And now the reason why we use function notation is because, for example, let's use the d of t. This statement right here, d of t, what that means is it means distance is a function of time. So that's just a short way of saying that distance is a function of time. And in this statement, it's easy to tell which is the dependent variable. Remember, we've learned this. Distance would be your dependent variable, and time would be your independent variable. So over here, distance is your dependent variable, time is your independent variable. It's very easy in this little short statement, d of t. It's easy to figure out which one represents my independent variable and which one represents my dependent variable. So that's typically why we use function notation when we're dealing with quantities. So we're going to get started to evaluate function notation. So numbers 1, 2, and 3 say we want to use function notation within each relation, because 1, 2, and 3, they are all relations. They are a set of ordered pairs. So what f of 0 means, whatever's in parentheses is always your x value. So we want to find the y value that is paired with the x value of 0. So looking at all my x values, I'm finding which one of my x values is 0, which is this one here, and the y value that it's paired with is 2.5. And that's all you would do to evaluate f of 0. Now, in the second part, it says f of x, which again, f of x is just a fancy way of writing y. So this is essentially saying y is equal to 6.5, and we want to find the x value that is paired with the y value of 6.5. So looking at my y values now, I'm going to find the y value of 6.5, which is this one here, and my x value that's paired with that is an x value of 4. All right, number 2, same thing. I want to find f of 4 whenever we have a number in our parentheses that represents an x value. So I'm going to look at all my x values and find which of my x values is 4, which is this one here. And now I want to write down the y value that it's paired with, which is 9. And then going backwards, f of x is equal to 5 essentially means y is equal to 5. And so we want to find the x value that's paired with the y value of 5. So we look at all of our y values, we find the y value of 5, which is this one here, and the x value that it's paired with is 0. Number 3, f of 2. Really just means that x is 2 and I want to find the y value that's attached with that x value of 2. So looking at my x values, I find the x value of 2 and the y value that's paired with that is a 3. Now, f of x is equal to 3 is essentially just asking you that y is equal to 3 and I want the x value paired with the y value of 3. Well, I have 3 y values of 3, so I'm going to write down all the x values associated with that, which is 2, 4, and 6. All right, so that's using function notation with a relation. Now we're going to use function notation to find values within a table, which is very similar to a relation. So I want f of 4, which remember if it's in parentheses, that's really an x value. So I find the x value of 4, which I actually have 2 of them, and I write down the y values that are paired with that, which are 5 and 8. All right, looking at f of x is equal to 5 is basically the same thing of saying y is equal to 5. So looking at my y value, that's 5, that's this one here, and the x value that's paired with that is 4. All right, number 4, I want f of 7, so I'm going to look at my x values first. The x value of 7 is here, that's paired with this y value of 0. Now I want f of x is equal to 6, which is essentially just y is equal to 6. So the y value of 6 is here, and the x value associated with that is -4. So that's how we do these evaluations based off of a table. Now I'm going to look at using function notation within a graph. So I want f of 2, so that's when x is 2. So I'm going to look at 2 on my x-axis, which is right here. The point that's in line with that x value of 2 is this point right here, which is the ordered pair 2, 2. So the y value associated with the x value of 2 is a y value of 2. Now I want f of x is equal to 0, which is essentially just y is equal to 0. So on my y-axis, y is 0 is right here, and the point that's in line with that y value of 0 is this point right here, which that's the ordered pair -1, 0. So when I have a y value of 0, that's paired with the x value of -1. All right, number 6, I want f of -1, which just means x is -1. So -1 on my x-axis is right here. The point that's in line with that x value of -1 is this point right here, which is the ordered pair -1, 2. So the y value associated with the x value of -1 is 2. Now I want f of x is equal to 2, which means y is equal to 2. So on my y-axis, the y value of 2 is right here. Well, that actually is going to, there's 3 points in line with that y value of 2. I'm going to highlight them in yellow. There's this point, which is the ordered pair -3, 2. There's this point, which is the ordered pair -1, 2. And then there's this point over here, which is the ordered pair 5, 2. So all the x values that are associated with a y value of 2 are -3, -1, and 5. We write them all down. All right, number 7. I have f of 3, which means x is equal to 3. So on my x-axis, 3 is right here. There are 2 points in line with that x value of 3. There's this point and this point. The upper point has the ordered pair of 3, 2, and the bottom point has the ordered pair of 3, -2. So the two y values that are associated with an x value of 3, I'm going to write them from least to greatest, are 2, -2. Now I want f of x is equal to -4, which is essentially when y is equal to -4. So on my y-axis, -4 is down here, and there's actually no points on my graph that are in line with that y value of -4, so this is actually none. All right, number 8, I want f of 1, so that means x is 1. So on my x-axis, I'm going to find 1, which there's technically only one point that's in line with that x value of 1, and that's this closed dot right here. The open dot is not a point on your graph, so we do not include that. The closed dot is the ordered pair 1, 1. So the y value that's associated with an x value of 1 is a y value of 1. Now I want f of x is equal to 3, which is the same thing as y is equal to 3. So looking on my y-axis, that's this area right here, I have a lot of points here. X is 3, x could be 3.1, x could be 3.2, x could be 3.3, and so on. So we're actually going to write this as an inequality. X can be greater than or equal to 3, but also must be less than 4. It cannot be equal to 4 because there's this open dot here on the x value of 4. So that would be your answer there. Now we're going to use function notation to find values within each equation. So what I want to do for number 9 is this is an x value of 4. All I'm going to do is put 4 in for x. So I have a 3 times a 4 minus a 5, which comes out to be a 7. Now f of x is equal to 0 means we want to replace this f of x with 0 and find out what x is. So I'm going to solve this equation for x by adding 5 to both sides, and then now dividing by 3 on both sides. So I get x is equal to a 5/3. All right, we're going to do the same thing in number 10, but I'm going to actually skip to number 11 for right now. So for number 11, we are going to put -2 in for x. When I put -2 in for x, I wind up, notice how I put that -2 in parentheses. A -2 squared is the same thing as a -2 times a -2, which is a +4. So I have a +4 plus a 2, which is a 6. All right, we're now going to work on number 11. Now this one's a little bit tricky because I want f of -2. So I'm going to start with my innermost parentheses, and basically what I'm going to do here is I'm going to find f of -2 by putting -2 in for x. So I have a 6 times a -2 plus a 2, which a 6 times a -2 is a -12, plus a 2 would give me a -10. So I'm going to replace the f of -2 with a -10 because f of -2 is -10. So now I have f of -10, which means I'm going to put -10 in for x in my same function, and I'm going to have a 6 times a -10 plus a 2, which I get a -60 plus a 2, which comes out to be a -58, and that is your final answer. I'm going to skip over number 12 for right now because that's very similar to number 11, and I want to really quickly do number 13. I want f of 2, which means I put 2 in for x. So I have a 2 times a 3 squared. We need to follow the order of operations, which states we do the exponents before the multiplication. So I'm going to do a 3 squared first, which is a 9. Now I do the 2 times the 9 to get an 18. I'm going to have you pause the video, try 10 and 12 on your own, then resume to check your answers. And here are your answers with the work shown.